All right, page 2. We are talking similar right triangles. So if you remember, we had the relationship that if we called this middle part h and these x and y, then h squared is equal to x times y. And then if we called this a and this c, we'd get a squared equals x times c. If we called this guy b, we'd get b squared equals y times c. We talked about how we only ever square a leg, or we square the altitude, and that when we are squaring the legs, it's always the leg with the side adjacent, so next to it, and then other side, the leg and the side adjacent to it. So that was our relationships that we talked about with altitude to the hypotenuse. So when we're looking at a problem like letter 3A or number 3A, we're looking for the altitude, and we have the two parts. So it's as simple as h squared equals 20 times 5. So h squared would equal 100, or h would equal 10. No need for plus or minus because it is a length. Now I know some of you all worked with Mr. Wooten, and he likes to do geometric mean. So that would be the same thing. We would put the h as the geometric mean, and then 20 and 5 would be our other two sides. I have an extra step here to cross multiply to get to here. On letter B, it's the same idea, but this time we're given a leg. So we're given this guy. So a squared is equal to, and these are part times whole. So the adjacent side, part, times the whole side, 18. So a squared is equal to 90. So a is equal to the square root of 90, which is radical 9, radical 10, 3 radical 10. I am leaving it in simplified radical form because that's what my instructions say to do. All right, next three are 30, 60, 90 triangles. All it says is for me to find the missing side, but I am looking at the problem and I see a 30-degree angle, a 60-degree angle, or a 30-degree angle, along with right angles on each of the triangles. So in a 30, 60, 90, if you remember, the side across from 30, if I label that as x, this is 2x, and this is x radical 3. So here's my x, or my single. The side across from 90 is double whatever this is. So that's 2 times 7, or 14. And the side across from 60 is 7 radical 3. So I've got 14 here. So this is 14, and this is x radical 3. If we look at letter B, we have to look at what we're given. We're given the side across from the 60-degree angle, and so that's equal to x radical 3, or this is my single radical 3. So the side across from 30, which in this case is y, would be whatever the coefficient of the radical 3 is there. So that would be a 5, and then the side across from 90 would be double this side. So 2 times 5, or 10. And our last one, we are given the side across from 90, which is double the single side, or double 2x, so equal to 10 radical 3. So I'm going to divide by 2, and 10 divided by 2 gives me 5 radical 3. So that's this side across from the 30, so 5 radical 3. So now we need the side across from 60, so we take our 5 radical 3 and multiply it by a radical 3. So 5 radical 3 times radical 3 is 5 times 3, or 15. All right, last two on this page are the 45, 45, 90 triangles. And so I am given that the side across from 45 is 12, which means the other side is 12 because it's an isosceles right triangle. So that's y, and then this guy is that radical 2. Now, if you get stuck, don't forget, you can always use the Pythagorean theorem if you know it's isosceles, and you could solve that for x. So you can always get back to the 12 radical 2. And it looks like I made that 12 radical 3, which is incorrect, and should be 12 radical 2. When I look at letter E, I can see that I have the side across from 90, so 12 is equal to x radical 2. And we talked about how we solve by multiplying by radical 2 on both sides. So I get 12 radical 2 is equal to 2x. Why is that? That is because when I take radical 2 times radical 2 in my calculator, I get a radical 4, and that gives me 2. If you don't believe me, check your calculator. It will not lie. I divide each of these by 2, and so I get 6 radical 2. Well, this is an isosceles right triangle, so these are both 6 radical 2.